students, this is Sanjay sir from Mathswell YouTube channel. Today we are going to discuss about one of the important topic from the mathematics which will help for the grades, higher secondary grades, that is 11, 12 and higher studies also. So here we are going to study about the complex numbers. So in the today's video we will see the definition of complex number, then some simple examples related to the complex numbers. Okay, so let's first start with the definition. So students, what is the need of this complex number? That first we will see. So in the in the algebra, one concept is there of square root of numbers, square root of real numbers, right? So we know how to find the square roots of the numbers. We know various methods of finding the square roots if the number is not a perfect square or if it is perfect square, then also we use that different methods. So we know the square root of some numbers, like square root of 4 can be written as plus minus 2, square root of 16 can be written as plus minus 4, and so on. So every square root will have every number will have two square roots. They are positive and negative. In the real numbers, we can find the square root of all real numbers, all the positive real numbers, right? So that is very important. So we can find the square roots of all positive real numbers. Any positive real numbers will have its square root. So if it is a perfect square, we can have it directly. If it is not a perfect square, we have different methods of finding the square root. Okay, so why the complex number can be introduced here? So as we have seen, the square root of all positive numbers can be found. So the question arises whether the square root of negative number exists or not, or whether it is a real number or not, or if it is not a real number, are you able to find the square root of such negative numbers? The question is yes here. So how it can be obtained? We can obtain it like this. We can factorize this minus 4 as minus 1 into 4. We can split the square root like this, square root of minus 1 into square root of 4. Okay, as we know, the square root of 4 is plus minus 2, and we don't know about the square root of minus 1. Here we have we can introduce the complex number. So here if I denote this square root of minus 1 by I, then we can have the square root of such negative numbers. So we can say that the square root of negative number will also exist, but it is not a real number, but it is a complex number or imaginary number. So the need of the square root of minus 1, so introduction of the square root of minus 1 will introduce the new type of number known as a complex number. So what do you mean by complex number? In general, the complex number, we denote the complex number by Z, and it is expressed as a plus ib, or in some cases it may be written in the form of x plus iy, either x plus iy or a plus ib. Some different publishers may use different notations. Okay, either a plus b or x plus iy. But the what are these a and b or x and y? Here this a and b or x and y, they are all the real numbers. So this complex number again is defined with the help of real number only. Okay, so z equal to a plus ib or x plus iy is called a complex number. In general, we can define as a number in the form of a plus ib is called a complex number, where a and b are the real numbers, okay, and I is called the imaginary unit whose value is root of minus 1, right? So this is a imaginary unit. We call it as a imaginary unit. Okay, so with the help of the two real numbers a and b and an imaginary unit minus root of minus 1, we can define a complex number. Okay, so the number in the form of a plus ib is called a complex number. So we have these A and B as the real numbers. They have some specific names. A is called the real part of complex number Z, real part of Z, whereas B is called imaginary part of Z. Or imaginary part of complex number Z. So A and B are the real and imaginary parts of the given complex number. Okay, if Z equal to A plus IB is a complex number, then we can say A is a real part of Z, B is a imaginary part of Z. Why they are called real part and imaginary part? Because here A is free from the imaginary unit I, so it is purely a real number. So we can say it is a real part of Z. Whereas B is in terms of or in the multiple of the imaginary unit I, so that this B is called the imaginary unit or imaginary part of Z, not imaginary unit, but it is imaginary part of a complex number Z, right? So student, in this way we can say that Z equal to A plus IB is a complex number. So as in case of the real number, the sum, product, quotient and the division of the two or more than two real number exist in real number only. Now we will check whether the sum, product, quotient and the difference of two complex number will also exist or not. So that is called the algebra of complex number, right? So let's see, let's discuss about it and then we'll move ahead for the next part of this topic. So let us discuss the algebra of complex numbers. So what are the algebras of complex number? We have the first one, that is the addition of two complex numbers. So we denote the two complex numbers as Z1 and Z2. So let Z1 be A plus IB or A1 plus IB1 and Z2 is A2 plus IB2. Okay. So we define Z1 plus Z2 as a sum of two complex numbers. Now we'll check whether the sum of two complex number will also be a complex number or not. So Z1 plus Z2 is equal to, so Z1 is A1 plus IB1 plus Z2 is A2 plus IB2. So we can simplify, we can take the like terms together. So here A1 and A2 are the real parts, we can take them together, A1 plus B1, sorry, A1 plus A2 in one bracket, and another remaining part, there is the imaginary part of the complex numbers, they are IB1 and IB2. If I take I common from it, I can have B1 plus B2. So A1 plus A2 plus I times B1 plus B2, which is equal to, so now students, as A1, A2, B1, B2 are the real numbers, so can I say A1 plus A2 and B1 plus B2 are the real numbers? Are they real numbers? Yes, this A1 plus A2, B1 plus B2, they are also real numbers. So can I denote them as A1 plus A2 as A and B1 plus B2 as B? So what can I have here? I can say the Z1 plus Z2, the sum of the two complex number, is also a complex number. So here I can say that Z1 plus Z2 is also a complex number, or the sum of two complex number is also a complex number. Understood? Now let's move ahead for the difference of two complex number. What do you mean by difference of two complex number? Whether the difference of two complex number exists or not in a complex number. Difference of Z1 and Z2 again. Okay, so as we know, Z1 and Z2 are the two complex number denoted by A1 plus IB1 and A2 plus IB2. So I can take the difference of them, A1 plus IB1 plus A2 plus IB2. Sorry, it is not plus, it is minus. Difference, we are taking the difference. So we can open the bracket, A1 plus IB1 minus. So as the minus sign is there outside the bracket, we need to change the sign of each term inside the bracket. If you remove the bracket, the sign will change. So A2 will become minus and IB2 will also become minus. So minus IB2. A1 plus IB1 minus A2 minus IB2. So now again collecting the like terms together, the real parts together, a1 minus I2 can be taken together in one bracket, plus in the imaginary parts, if I take I common, so I left with b1 minus b2. So again students, as a1, a2, b1, b2 are the real numbers, so their difference will also be a real number. So here I can say a1 minus a2 as well as b1 minus b2 both belongs to the set of real number. So I can denote again the difference of two complex number as I, a, and difference of the two real numbers b1, b2 as b. I can say that the difference of two complex numbers z1 and z2 is also a complex number. So hence we can say the difference of two complex number is also a complex number. Now we'll come to the third one, the third algebra of the complex number, that is called the multiplication of complex numbers. Multiplication of complex number, say z1 and z2. Okay, so how it will be obtained? Let us see. It's very simple. Again consider z1 and z2 are the two complex numbers. Again they are denoted, defined by a1 plus ib1 and a2 plus ib2. So here I have z1 into z2 equal to z1 is a1 plus ib1, z2 is a2 plus ib2. So here it is a product of two binomials. We can treat it as a product of two binomials. Now if we take the product of two binomials, how the binomial can be simplified in the real numbers? We can do it like this. So we first take the first term of the first binomial, it is multiplied to the second binomial. So it is a1 times a2 plus ib2 plus the second term of the first binomial, that is ib1, is multiplied to the second binomial as it is a2 plus ib2. Now if you open the bracket, what will happen? a1 into a2 will become a1 a2, a1 plus ib2 will become I times a1 b2, plus ib1 is multiplied to a2, it will become I times a2 b1, plus I into I will become I square and is multiplied by b1 b2. Now students, can you tell me, if I know, as we know I is equal to root of minus 1, so can you define I square? Can you have the value of I square? So if I square this equation, that the I equal to root of minus 1, so what I will have? I will have definitely minus 1. So I can use the value of I square. Wherever there is I, we can find I square, and that will be equal to minus 1, as I is equal to root of minus 1. So student, here I can rewrite a1 a2 plus, so here I have the two terms of I in linear form. I can take I common from this, and I left with a1 b2 plus a2 b1 in one bracket, and then using this value of I square is minus 1, so I can write only minus sign for b1 b2. So again I have the two real parts, two real numbers a1 a2 and b1 b2. So taken the like terms together, a1 a2 minus b1 b2 in one bracket, plus I times a1 b2 minus a2 b1, right? So again, as we know, a1 a2 b1 b2 are the real numbers, their product as well as the difference of the products will also be a real number. So these two brackets, this one and this one, both are the real numbers, so I can denote them as a and b again as usual. So it is a plus ib as again a complex number in the standard form of a complex number. So hence I can say the product of two complex number is also a complex number. Understood students? Okay, fine. So now let's move ahead for the fourth one, the fourth algebra, that is called the quotient or the division of two complex numbers. Division of two complex numbers. What are the division of two complex numbers? Let us see. So as usual, z1 and z2 are the two complex numbers. So division or the quotient of two complex number is z1 upon z2. So write the complex numbers. z1 is a1 plus ib1, z2 is a2 plus ib2. So now students, to simplify this, I need to introduce one term known as the conjugate of complex number. What do you mean by conjugate of z? So as I know, z is a plus ib. As z is a plus ib, what will be the conjugate of z? I denote the conjugate of z by z bar, and is nothing but, or it will be obtained from z just by changing the sign of the imaginary part. That will give us the conjugate of z. So it will be equal to a minus ib. So that is called the conjugate of z, conjugate of a complex number. So with the help of this conjugate, we are able to simplify this quotient of two complex number. So in this case, students, what we need to do, we need to multiply and divide by the conjugate of the denominator complex number, that is z2. So what is the conjugate of a2 plus ib2? Obviously it will be a2 minus ib2. It is divided by the same one, that is a2 minus ib2. So multiplying, dividing by the conjugate of the denominator complex number. So now it will help us to simplify this division of two complex numbers. So how it can be simplified? So as we know, it is a product of two fractional functions or rational numbers, or fractional functions. Here we can say, we can just multiply numerator with numerator and denominator with denominator. So what we have, we can take the product of a1 plus ib1 is multiplied to a2 minus ib2, and in denominator we have the product of a2 plus ib2 to a2 minus ib2. So what will this gives us? In denominator, what we have, denominator is the product of two binomials in which the first one, if it is a plus b, the second one is a minus b. So it is the product of two such binomials, or we can say it is the product of two binomials in which the first bracket has the addition, second bracket has the difference. Or we can say in algebra, a very well known product or very well known identity we have, we can say the formula a plus b into a minus b. A very well known formula is there. So it will be equal to a square minus b square. So using this, so can I apply this formula here? It is a2 plus ib2, a2 minus ib2. So here if I compare this one with a plus b, a minus b, it will be a will be equal to a2, b will be equal to ib2. So the same is here. So now applying this formula, what we have, a square means a2 square minus b square means ib2 square, and in numerator we can just simplify, or we can just multiply the binomials. So what we have, multiplication of binomials, as we know in the multiplication, we follow the same steps here. So a1 is multiplied to a2 minus ib2 plus ib1 is multiplied to a2 minus ib2. So what this gives us? It gives us the denominator a2 square minus now it is a square of I and b2 both separately. So I can write it as I square into b2 square, whereas in numerator I just simplify the brackets, open the bracket. So it will become a1 a2 minus I times a1 b2 plus I times a2 b1 minus, here again I have I into I square, then it is multiplied by b1 b2. So again, as student in the previous, that is a multiplication of two complex numbers, we have seen, we have the value of I square. Value of I square is equal to minus 1. So wherever there is I square in the complex number, we can put it as minus 1. Okay, so it will be a1 a2 minus I times a1 b2 plus I times a2 b1, and here I square is minus 1, so this minus with minus sign will become plus b1 b2, and is divided by, in denominator what I have, a2 square, again I have I square, so I should be minus 1. With this minus sign, that will become plus, and it will be b2 square. So a2 square plus b2 square. So what this gives us? So now in numerator again we can collect the similar terms, we can collect the like terms together in one bracket. So we have a1 a2 plus b1 b2, which are free from I, that is real parts, taken together, and from the remaining two terms of I take I common and I write the remaining terms, their coefficients a2 a1 minus a1 b2, sorry, a2 b1 minus a1 b2, right? So it is divided by a2 square plus b2 square, right? So what this gives us, students? So here we have the numerator again in terms of I, so I can rewrite it as a1 a2 plus b1 b2. So can I divide each of these two terms by this denominator? Yes, we can divide. Since it is a positive number, I can divide to both by this a2 square plus b2 square, plus I times, again I divide this a2 b1 minus a1 b2 by the denominator a2 square plus b2 square, right? So again we have these two brackets, this one, the first one, and this is the second one. So these are the two brackets. So can you say these brackets are the real numbers? Because it will not have any imaginary part or imaginary unit, so we can say they are real numbers, as we know the sum, product, quotient, and difference of any two real number will again a real number only. So again denoting these two brackets as a and b respectively, first bracket as a, second bracket as b, I can have the quotient of two complex number again in the form of a plus ib. That is, I can say that the quotient of two complex number is also a complex number only, right? So in this way, students, we come to know that the algebras of complex number, that is the sum of two complex number, product of two complex number, difference of two complex number, and the quotient of two complex number will also be a complex number. One more algebra is there, that is called the scalar multiplication. Will it be again a complex number? Yes, it should be. As we know, z is a complex number, a plus ib. If I denote k is any complex, scalar, so z is a complex number and k is a scalar, so I can rewrite it as k times z is a plus ib, so it will be equal to ka plus I times kb. So k, a and b here all are real numbers only. K is a scalar, a and b are also the real numbers only. So you can say the k into a, k into b will also be the real numbers. If I denote by some capital A and this as capital B, so you can say that the scalar multiplication will also be a complex number only. So in this way also we come to know that the scalar multiplication of a complex number will also be a complex number. So this is the introductory part of the complex number, students. So it's very important. It's a new concept of the numbers. Till today we have only seen the real numbers. Beyond that we have one more type of a number known as a complex number. So it will help us to find the square root of negative number. So with this note, today we stop here only. In the next video we will see the remaining part of this topic as well as some very important sums on the important concept of this topic. Okay, so with this note we will end the session today. We will continue the remaining part of this topic in the next video. Hope everyone understood this. Thank you.